Welcome to this video tutorial, one of many in a series designed to get you up and running with Leapfrog. This video is part 2 of 4 discussing basic geological model building. In this video, I will introduce the different surface types available in Leapfrog and how they interact with each other. Once built, the surfaces are used to form interlocking geological model volumes. Leapfrog creates surfaces using a radial basis function. These are mathematical functions which create smooth surfaces between a series of points. One of the common inputs to Leapfrog is drill hole data. Once the drill hole data is in the Leapfrog project, the user can decide what type of geological surface is most appropriate. Leapfrog essentially takes the drill holes and puts contact points at the contacts between different units. Leapfrog then passes a surface through these contact points. Different surfaces follow slightly different methods. Don't worry if you don't know what surface to use for your project yet, as that's the topic for this video. Because Leapfrog creates surfaces directly from drill hole data, surfaces can be easily updated. For example, if an additional drilling campaign is provided, the new drill holes can be imported into Leapfrog and the surfaces will be automatically updated to include the new information. This dynamic updating represents a huge time savings, as models don't have to be started from scratch with the addition of new data. The Surface Chronology subfolder in the Geological Models folder contains 4 different surface type functions: new deposit, new erosion, new intrusion, and new vein. I'll start by explaining the functionality of the new deposit and the new erosion surface types. New deposits and erosions create exactly the same surfaces. The only difference between them is when the surfaces are activated to produce output volumes. For both deposit surfaces and erosion surfaces, we can take a single lithology code, in this case we'll use the red as the example, and tell Leapfrog to find the points at which the red lithology contacts either above or below against other lithologies. In this case, it contacts the orange unit twice and the yellow unit 3 times. Leapfrog extracts the points at these locations and then puts a surface through the points. Now that we've seen how Leapfrog makes the surface, I'll explain the difference between the functionality of a deposit surface and an erosion surface when it comes to creating volumes. In this example, which is in section view, the two surfaces, the red-yellow and the yellow-orange, are identical to those in the erosion example and are both represented by black lines that intersect each other. In this case, as both surfaces are listed as deposit, the younger surface stacks on top of the older surface, and when the volumes are created, it results in stacking depositional units. In this example, you can see the two surfaces represented by the black lines are identical to those in the previous example for deposits. However, in this case, as the red-yellow surface was created as an erosional surface, it cuts or erodes the older underlying depositional surface. New intrusions are used for modeling a surface around a particular lithology. We can take a single lithology code, in this case the yellow lithology, and tell Leapfrog to find the points at which the yellow lithology contacts against all other relevant lithologies, in this case the red and the orange. Leapfrog extracts points at these contact locations and then puts a surface through those points. The points are made up of contact points and volume points. As we can see, the contact points are green and represent the points at which the two lithologies contact against each other. The volume points represent the inside, as we see here in red, and the outside, as we see here in blue, of that surface. When we create volumes in this case, it will look something like this. The vein and vein system tool are both suitable for modeling thin tabular volumes. We start by specifying the lithology that is inside the vein in this case, the green unit. Leapfrog will then take each interval of that lithology and assign a hanging wall point to the top of the interval and a footwall point to the bottom of the interval. Each set of points will then be surfaced to produce a hanging wall surface and a footwall surface. Now that you have a better understanding of the different surface types in Leapfrog, check out the next video in this series in which I demonstrate them in the software.